right, so in Unit 4, Lesson 2, you are writing rules for linear functions. We already practiced some of this in the last unit, so this is a little bit of a review, but let's go through it. Write a function rule for finding the amount of daily pay, P, in the following situation. A bus driver gets paid $100 each day plus 50 cents per kilometer, K. All right, so when we write a function rule, the way that I always like to write my rules is y equals mx plus b. And if you remember back to the last unit, that is slope-intercept form, where m is the slope and b is the y-intercept. Now, we're not really looking at it in slope-intercept form. We're not graphing it or anything right now. We're just trying to write the rule or write the equation. So the way I like to think of it, remember, slope is your rate of change. And then y-intercept is like your starting value. It's where you start on the y-axis. So if we think about this situation, it says a bus driver gets paid $100 each day. That's his starting point. No matter what, he is going to make $100. So that is actually going to be our y-intercept. And then he makes plus 50 cents per kilometer. So that is your slope. You know, if he drives 1 kilometer, he makes $100.50. If he drives 100 kilometers, you would be $150. So this is the amount that's changing depending on how many kilometers he drives. So this is the one that changes. So this is the slope. And if we write that out in our y equals mx plus b form, the slope would be 50 cents and the y-intercept would be $100. Now, this is how I like to think of it because I just like to think of slope-intercept form. It's my favorite form. Something that you might notice if it's a multiple choice answer, though, is that it's using different letters. It's not using y's and x's. So the total pay would be y, and then k is per kilometers. And remember, it's 50 cents per kilometer, so k would be x. Okay, let's look at another one. Do the values in the table represent a linear function? If so, what is the function rule? All right, so you can check if they're a linear function a couple different ways. You could quickly sketch a graph and you could plot these points, -2, -4, 0, 0, +2, +4, and then 4, 8. So you could kind of sketch a graph to see if it makes a straight line, which mine is not straight, but pretend it's straight, then yes, it's a linear function. That's one way you could tell if it's a linear function. The other way that you could tell if it's a straight line is to see if it has a constant rate of change or a slope. Remember, the definition of slope is constant rate of change. It has to have the same rate of change the entire time for it to be linear. If you saw a t-table that was adding 2 and then adding 3 and then adding 4, that would not have a constant rate of change. Remember, the word constant means it's always the same. So let's go ahead and look at our t-table. We can do this a couple ways. We can use the slope formula, or you can find your common difference. Remember, with arithmetic sequences, you can find a common difference. So from -2 to 0, we're adding 2. From 0 to 2, we're adding 2, and we're adding 2. And then if we look down here, we're adding 4. And remember, slope is rise over run, or the y value over the x value. So we can look at this t-table and say our slope is 2. You could also go back here to the graph that you sketched and figure out that it's 2 because you rise up 4 and over 2. So your rise over run would be 4 over 2. Or you could plug in points to the slope formula. So I'm just going to use these. Well, I'm not actually going to do that right now for time's sake. But because it has a constant rate of change, we know that it is a straight line. Okay? And we also know it's a straight line because we sketched the graph. So we can get rid of that one. And now when we want to write the function rule, remember when we write our function rule, I like to use slope-intercept form, where m is the slope and b is the y-intercept. We already solved for the slope. We know the slope is 2, so it can't be 1/2. And then the y-intercept is whenever x equals 0. If you look at the graph, it's wherever it crosses the y-axis. If you look at a t-table, it's the y value whenever x is 0. So my y-intercept here is 0. So my equation would be y equals 2x plus 0, but we don't normally write the 0, we just write 2x. So that is it. Write an equation for the line shown in the graph. So again, for an equation, we're going to use slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. I like to find my y-intercept first. So y-intercept is wherever it touches the y-axis. So you're just going down the y-axis until it crosses. That's your y-intercept. So my y-intercept is at positive 3. So I know for my b value, I'm going to have a positive 3. And then for my slope, it's going downhill, so I know my slope is negative. And so now I just need to count the rise over run. So I'm going to pick points that cross the grid. Remember, when you do slope, it does not matter which points you pick because it's a straight line. The slope has to be the same no matter which points you pick. So I'm just going to pick these bottom 2. I'm going to rise up 2, and I'm going to rise backwards 1. And so that gives me 2 over negative 1, which is the same thing as negative 2. So here's my equation, y equals negative 2x plus 3. And you could, let me go back here. You could always double check yourself using Desmos. I love Desmos. It will graph things for you. So if I go over here and I type in y equals negative 2x plus 3, I just have to look and make sure that that graph is the same as this graph, which it is. So that's a way you could double check. All right, for the next question, write a function rule for the total cost. A store sells frozen yogurt for $2 per cup plus $1.25 per topping. Write a linear equation to show the total cost of a cup of frozen yogurt. All right, we're going to do that part first. We're going to write the linear equation first. And for my linear equations, I love slope-intercept form, so that's what I'm going to use, where m is the slope and b is the y-intercept. Okay, remember slope is the rate of change. So the slope is how much it's changing each time, and b, or the y-intercept, is like the starting value. Like if I go back to graph an equation, I start by putting a point on the y-intercept. That's my starting value. And then from there, I would do my slope. I would rise down to over 1, down to over 1. That's how you graph it. So if you're thinking about a word problem, instead of thinking as the y-intercept as like where it crosses the y-axis, you can think of it as the starting value. So if I look at my equation, a store sells frozen yogurts for $2 per cup. That's my starting value. So that's going to be my y-intercept plus $1.25 per topping. That's the amount that changes. If you get 1 topping, it's just $1.25. If you get 2 toppings, that's $2.50. If you get 3 toppings, so on and so forth. That changes each time. So this is your rate of change, which means that's the slope. And now we go to plug them in our formula. The m is our slope, which is $1.25, and the b is our starting value, which is $2. So this is our formula. So we've written the linear equation, and then it says to calculate the total price of 1 cup of frozen yogurt with 4 toppings. So we know the starting price is $2, but now we also know that we have 4 toppings. So we're going to plug in a 4 here for x. 1.25 times 4. And remember, when you substitute things in, you want to make sure you put them in parentheses. That'll just help you keep it straight when you go to the calculator. So, oops. So 1.25 times 4 plus 2.00. So the total cost would be $7. And since it's money, we're not just going to write it as 7. We're going to, since it's a real world problem, we're actually going to write that as $7. So this was your rule, and this was your cost for an ice cream with 4 toppings. And that's it. Good luck on this quick check.